Okay, we are picking up in part of section 3.6. You'll notice we skipped 3.5. 3.5 talks about rational functions. It's kind of too big to all go in one unit. So we are skipping 3.5. We'll start it in our next unit. 3.6 deals with both polynomial and rational inequalities. So we'll visit here with polynomial inequalities, and then we'll come back to 3.6 and talk about rational inequalities in the next unit. Inequalities. What's the difference between an equation and an inequality? Well, an equation has an equal sign. Inequalities have less than and greater than signs, or also could be or equal to. So here we go. All right, so this is my greater than. This one is greater than or equal to. Because it has part of that equal sign with it. So greater than or equal to. And then if I'm opening in this direction, it's less than. And then of course here is less than or equal to. Now, sometimes it's really hard to remember which is which. One of my kids showed me that if you take your fingers and you make the inequality symbols, if you straighten them out, the one that looks like an L is the less than. L is less than. The greater than is backwards. So anyway, that's how we deal with inequalities. Those are my symbols. Now I stole this from someone, and it should have arrows on the end. What type of function is this? What do you know about this function? Well, I know it's at least a third degree polynomial, right? Possible degree. Third, it could be fifth degree. It has to be odd. Must be an odd degree. Can't be even, because one ends up, one ends down. And in fact, we start low, finish high. So we're going to have a positive coefficient, not negative. Sometimes I can't talk and write at the same time. We're going to have a positive coefficient because it's increasing. Overall, we start low, finish high. Roots and multiplicities. Let's talk about that. Let's talk about roots and multiplicities. I've got a root here and here and here. 3 roots. They are all going straight across. So we have roots at, that looks like -6, -3, and +3. Each of them probably has a multiplicity 1 because it just shoots across. They don't slow down and flatten out. What about a y-intercept? That's another important piece of information. We've got a y-intercept right here. It looks like 11, 12, 13, maybe -13.5 for my y-intercept, close to that. We know this is a polynomial function because it's a smooth continuous curve. We've got a relative maximum and a relative minimum. So those are all good pieces of information we know about this graph. Okay, now let's think about what we're going to be comparing our equation to, our function to. Where is y equal to 0? Well, that's kind of a weird question. Y equals 0 is right here. This is the line, y equals 0. Y equals 0 on the x-axis. Y equals 0 at the x-axis. So let's look at this graph and talk about these inequalities that I've got. Let me get us a little more space on the screen. For what intervals is my function? This is my function f of x. This is my function f of x. For what intervals? Intervals on the x-axis. So we're talking about intervals on the domain. For what intervals is my function value, my y value, greater than or equal to 0? Well, if this line is y equals 0, the intervals where the function is greater than or equal to 0 are going to be the ones we can see there, because they are above or on the x-axis. So right here, this and this, so in here, my function value is greater than or equal to 0. And from this point on, my function value is greater than or equal to 0. Now let's think about this. We identified this as -6, -3, and +3. So my function value, my y value, is greater than or equal to 0 for the intervals on the domain from -6 to -3 inclusive, and from +3 forever, because it's just going to keep going up. So from -6 to -3 inclusive, or +3 to positive infinity. Now we're going to go down to this question. How is this question different from the one above? The only difference is that it's not or equal to. So since it's not or equal to, I'm not including those endpoints where I am on the x-axis where y is equal to 0. So my intervals are essentially the same, but I change from my square brackets that show or equal to my curved parentheses. Okay, so greater than 0, function value greater than 0 says, where's my y-axis? All right, I'm looking to see where my y values are positive. For this next one, I'm asking for function values, y values less than or equal to 0. Well, again, y is 0 here, so less than or equal to 0, that's going to be where my graph falls below the x-axis because I have a negative y value. That happens over here and in here. So for those two intervals on the domain. So we're doing intervals on the domain, on the x-axis, talking about what y is doing. Well, where is y negative? Y is negative we're on the domain from -infinity to -6, or -3 to +3. Inclusive because it's or equal to. When I move down here to this question, it is now not inclusive. So it's almost the same intervals, just I can't include those endpoints because it's not or equal to. All right, so inequalities, when I compare it to 0, we're comparing it to what's going on here at the x-axis. Am I interested in greater than? Then that's above the x-axis. If I'm interested in less than, then those are negative y values, so that's below the x-axis. Okay, this is a really kind of short and nice way to end our unit. I've got 2 more graphs here. We're going to talk about where those inequalities would fall. I apologize, we're a little blurry, not too bad. So for this one, solve for f of x greater than or equal to 0. Greater than is above. Y is 0 is my x-axis. So if I'm interested in greater than or equal to 0, I'm interested in these parts where my graph is up above or touching. Ooh, or touching right there, or touching the x-axis. Greater than or equal to. That is where my graph is greater than or equal to the x-axis. So I've got this first interval on the domain from -infinity up to, that is -3 inclusive. Or I come up and my graph touches the x-axis here. So I've got to include that single value 2, I put it in fancy braces, or this last interval starting at 5 to positive infinity. What if I changed my question? What if I made a change in my question and I said, where is my function value greater than 0, not or equal to? Well, what difference does that make? That difference is going to be, I don't include -3, I use my curved parenthesis. If I'm not interested in equal to 0, I'm not interested in that value 2. So I've only got this interval and then that other end. All right, take a look at g of x here. Answer that, pause the video, answer that, and then come back. Here we're interested in less than or equal to 0, so I'm interested in the bits of the function that touches. And it looks like that's kind of tricky. It looks like that falls down below right there. So, so intervals on the domain compared to 0, y equals 0 there. We're giving the interval on the domain where the function value is negative or 0. Well, this interval, that's true. So negative infinity up to and including -5, or, and then it looks like that whole thing dips down right there, so that's going to be from 2 to 3 on the domain. All right, so what if we don't have a graph? That's where, if we've got our graph, we can read our graph, we can look to see where the graph is above or below the x-axis. Super easy, I love it. What if we don't have a graph? Well, if we don't have a graph, then we're going to use our test point method. Test point method lets us solve polynomial inequalities, and we use a very similar method for rational inequalities. Our first step, the first thing we need to do, is to express the inequality as set equal to 0. We need to make sure it's set equal to 0. We want to compare it to 0, nothing else. We may have to move terms over. If you have something on that right side of the equation, or excuse me, the right side of the inequality, you may have to move it back over so it's set to 0. For each of our inequalities we've been working with so far, we've been comparing it to the x-axis where y equals 0. That's what we need. Our second step is to locate what we're going to call boundary points. Our boundary points are those x-intercepts. Like that's going to be a boundary point, that's a boundary point, that's a boundary point, that's a boundary point. Our boundary points are our x-intercepts. We factor, set each factor equal to 0, and solve. We are doing that to find our x-intercepts. That's the steps to finding the x-intercepts. Our x-intercepts are our boundary points. Then we're going to graph, but we're going to do a quick and easy graph on a number line. We don't need to do a full xy coordinate plane. We're just going to sketch a quick number line, put our boundary points in the right order on our number line. That matters, least to greatest. Make sure you go in order. Then we're going to do our test points. We're going to test a point in each interval. Not the boundary points, but test a point inside, between the boundaries. You're testing to see if the value, the function value you get out is positive or negative, because, for example, if these are my two boundary points, if I pick -1 to test, I get out a negative function value. If I chose to pick +1 to test, I would get out a negative function value, because everything between those two boundary points falls below the x-axis. Any point that I plug in here is going to come out as a negative y value. So as long as I pick one point in that interval, it's going to give me a negative, and I know that everything in that interval is below the x-axis. Correspondingly, if I picked over here, if I picked 0 to test, it's going to give me a positive y value for an outcome, because anything between these two boundary points is going to be positive. It would be graphed above the x-axis. So I don't have to do the full graph. I can just pick one point in an interval, and it tells me where everything in that interval would fall. The solution set includes the intervals that satisfy the inequality. Am I looking for my pluses, or am I looking for my minuses, my positives or my negatives? Okay, so there are my steps for my test point method. Let's do a couple of examples. Keep this handy, 1, 2, 3, 4, 5. Set it aside so you can see it. Let's solve our inequality. Well, our first step says to express the inequality as set equal to 0. So my first step is going to be to move that 20 over. So I've got x squared minus x. I subtract it to move it over, greater than 0. I've set it to 0. The next thing I need to do is locate my boundary points so that I can then go to step 3 and graph it on a number line. This is going to be step 3 over here. To locate my boundary points, I need to factor it. Well, x times x is x squared. My constant is negative, which means these signs are going to be opposite. Factors of 20 could be 1 and 20, 2 and 10, 4 times 5. I need to pick the pair that will give me a negative 1x. If I pick 4 and 5 and make that a negative 5 and a positive 4, negative 5x, positive 4x gives me that negative x in the middle. So there's my factors. Think about setting each of those factors equal to 0 to get your boundary points. So I graph those boundary points on a number line. Negative 4 is to the left of positive 5. When I put my 2 boundary points on the number line, I see that I have 3 intervals. I've got the left end, the center, and the right end. So I need to test a point within each interval. Test a point within each interval. So I pick a point inside the interval, not one of the boundary points. We're going to pick easy values. Between negative 4 and 5, I've got 0, so I'm going to test 0. Something big and easy over here. Let's like negative 10. And then over here, let's do positive 10. So test our boundary points. I'm going to test first x equals negative 10. What if x equals negative 10? If x equals negative 10 and I put a negative 10 in here, all I care about is it positive or negative here? Negative 10 and 4 is a negative 6 times negative 10 and negative 5 is a negative 15. Negative times a negative is a positive. So everything in this interval is positive. Again, I don't care about the values themselves. I care about is it positive or negative. Now let's test x equals 0. Well, 0 plus 4 is 4. 0 minus 5 is negative 5. Positive times a negative is a negative, so everything in this interval is negative. And then I check positive 10. 10 and 4 is 14. 10 minus 5 is 5. Positive times a positive is a positive, so everything in this interval is positive. So we tested our points in our interval. We found out that if I were going to graph this, and that's what this is really showing me, is this graph would be up, cross, down, cross, up, and that follows our end behavior for what we've got here. Now I check to see, okay, what intervals am I interested in? The solution set includes the intervals that I'm interested in. I'm interested in knowing where my function is greater than 0, so I'm interested in those intervals where my function value is positive. So my intervals are from negative infinity up to negative 4, not inclusive because it's not or equal to, or 5 to positive infinity, and that's my solution. But this is the work that I need to show. So make sure that you are practicing testing points in the boundaries within each interval. All right, let's go again. Express the inequality as set to 0. That is already done for us. We don't have to do that. The second step then is to factor. We've got 4 terms. I'm going to do what we call factor by grouping. I group my terms 2 by 2. I look to see what the first 2 have in common. Well, they have in common an x squared, so I'm going to factor that out. When I factor out x squared, I'm left with x plus 7. And then I look at my next 2 terms, and whatever I factor out, I want to leave behind x plus 7, if this is going to be helpful. And I see that to leave behind an x plus 7, I could factor out a negative here. So I'm going to factor out a negative 1. That leaves behind x plus 7, and that is set less than 0. All right, next step to factor by grouping. I take my common factor, x plus 7, and I pull it out front. And then I group together what was left behind, x squared minus 1. And I've still got this set less than 0. I have to factor completely. This is fine. This is difference of squares though. And difference of squares breaks down to give me conjugate pairs. X plus 1, x minus 1. Square root of x squared is x. Square root of 1 is 1. So there I have factored it completely. I take my factors and I set them equal to 0 to find my boundary points. So I've got boundary points at -7, -1, and +1, which leads me to my third step where I set up my number line, and I need to put these in order from least to greatest. I'm not really worried about spacing, I just want to make sure I've got them in the right order. I put 3 boundary points on my graph. That gives me 1, 2, 3, 4 intervals to test. You'll always have one more interval than you did boundary point. So let's pick some values to test. 0 goes here between -1 and 1, so that's easy. I can do 10 here. 10 or 100 is a good big value for my ends. And then I need to pick something here in the middle. And it doesn't matter. Anything between -1 and -7. What if I do -3? I don't know. That's about halfway in there. So now I need to test those test points. I'm going to test x equals -100. I'm going to test x equals -3, x equals 0, and x equals 10. I'm testing it in my factors to see whether what comes out positive or negative. So if I put in a -100 here, whatever I do to it, it's still going to be negative, right? So -100 plus 7, -100 plus 1, -100 minus 1, each of those factors is going to be negative when I plug in a -100. I don't care about the actual value. I care, is this interval positive or negative? Well, a negative times a negative is positive, times a negative is negative. So everything in that interval is negative. Then I move to my next interval, and I'm going to plug in a -3. I've got to pay a little closer attention here. -3 and 7, well, that's positive. -3 and 1 is negative. -3 minus 1 is negative. But when I multiply that together, two negatives together cancel each other out, and everything in that interval comes out to be positive. When I plug in 0, that would leave me with 7 times 1 times -1. Positive, positive, negative, that's negative. And when I plug in 10, 10 and 7 is positive, 10 and 1 is positive, 10 minus 1 is positive. So everything in that interval is positive. All right, let's evaluate my inequality to find my solution. I'm interested in things that are less than 0, so I'm interested in those negative intervals. I don't get to include the endpoints because it's not or equal to. So everything on the domain from -infinity up to -7 or between -1 and 1 is going to be a correct solution to my inequality. Last one. Oh, this one's easy. We've got steps skipped for us. It's already set to 0. It's already factored. We can pick right up with our boundary points on our number line. Hopefully you've noticed that when I set these to 0, it changes the sign on the term. So this would be -8, -4, -3. Three boundaries gives me 4 intervals. I need to test each of those, something in each of those 4 intervals. 0 is going to be over here. Let's do -100 here. Between these two, let's do -5. I don't know, -5, -6, -7. Doesn't matter. Ooh, this is a little harder, right? Between 3 and -4. Let's do -3.5. All right. We're going to test these boundary value, or not boundaries. We're going to test the intervals. I encourage you to pause the video, give it a try, see what you got. I'm plugging that value into each of these 3 factors and seeing what's going to give me. Well, when I plug in -100, each of those is going to come out to be negative. And if I multiply 3 negatives together, it's negative. If I plug in a -5 here, that's going to be positive, that's going to be negative, and that's going to be negative. When I multiply that together, everything in that interval is positive. -3.5 is smaller than these two, so those 2 factors are positive values. This one's going to be a negative value. So positive times a positive times a negative is a negative. When I plug in 0, I have 8 times 4 times 3. Those are all positive, so that interval is positive. And finally, I am evaluating my inequality to see what my solution set is. Values less than 0 or negative, so I'm interested in those intervals. This time is or equal to. So when I set up my intervals on the domain, I get to include the endpoints. And there we have it. That's my solution to my inequality.